Today we're moving on to section 3.3, finding complex solutions of quadratic equations. So first we're going to look at this by graphing. So if we want to complete this table, they're giving us equations to start with. Then in the second column here, we're just going to subtract over the whole number. So we'll take 2x squared plus 4x equals negative 1. Now we're going to break it up the way we have been doing it before. We're going to look at what's the left side, 2x squared plus 4x, and then what's the right side, g of x then is equal to negative 1. We'll do this similar thing over here. This time will be equal to negative 2, and this time will be equal to negative 3. So we're going to graph these as we've done in the past. So we'll graph the left side of the equation. That's what they've done for us already, the 2x squared plus 4x. Now we're going to graph the right side, the horizontal lines. So the first one we should have is at negative 1. So this is at our line of negative 1, one at negative 2, and one at negative 3. So what we're paying attention to is the number of real solutions. So basically, how many times does our horizontal line intersect to the function? Well, for our equation, we're looking at the horizontal line of negative 1. It's crossing our function graph twice. When our horizontal line was at negative 2, it's touching our function graph exactly once. And when our horizontal line was at negative 3, it's not touching our function at all. So that's telling us how many real solutions there are based on how many times our horizontal line is touching our graph. So we can do the same thing here. The main thing to recognize this time is that our whole number at the end there, we're subtracting 1. So really when we move it over to the other side of our equal sign, it'll be a plus 1, positive 2, positive 3 over here. So we're going to do the same thing though. I'm going to draw a horizontal line at 1. I'm going to draw a horizontal line at 2. And a horizontal line at 3. Similar idea here, we're looking for the number of real solutions. So how many times does our horizontal line cross the function? Well, when our horizontal line was at 1, it crosses twice. At 2, it touches it exactly 1 time. And then at 3, it's not touching it at all. So as we reflect, look back at steps A and B, notice that the minimum value of f of x in steps A and B is negative 2. So that's the minimum value of the parabola. So the minimum value of the parabola in step A here is at negative 2. And then at, so complete the table by identifying how many real solutions. So when we were equal to negative 2, we had one solution. That's where we were touching our parabola exactly once. When our value was greater than negative 2, so that was where we looked at the function at negative 1. It was crossing it twice. And when we were looking at negative 2, that's when we were looking specifically at negative 3. It wasn't touching it at all. So that's telling us how many real solutions there are. The step C, similar idea here. This time, though, it's the maximum because that parabola was flipped upside down. So now our value is at a maximum. So that value was at 2. So when we were equal to, it had one solution. It was touching at exactly one spot. When it was greater than 2, it had 0 solutions. And it was less than 2, it had 2 solutions. So we can generalize some stuff from this equation here. The main thing we're trying to get to is right here. So the equation ax squared plus bx plus c equals 0, where a is greater than 0, has real solutions when b squared minus 4ac is greater than 0. Okay, so that's the key thing that we're looking at there. So we can find some of these complex solutions by what's called completing the square. This is another method we have for factoring. So recall that completing the square for the expression x squared plus bx requires adding b over 2, that quantity squared, resulting in a perfect square. So this you might want to see. We haven't seen it in a while. So we're going to solve by completing the square. So the first thing we do is move any whole numbers to the other side. Next thing we do is make sure the coefficient in front of our x is 1. So we have to add 6 to both sides and then divide everything by 3 so that the coefficient in front of our x squared term is just 1. So now you take that middle term, middle coefficient b, which is 3, and you take that middle term and you divide it by 2 and then you square it. So we took 3 over 2 and then squared it to get 9 over 4. This one's a little bit of a complicated one. They're not all this bad. But then you have to add it to both sides. Once you've added it to both sides, the way we created this, we set it up so that we would have a perfect square over here. So that b over 2 squared, or that b over 2 portion is what's inside of our perfect square. So here they added the 9 over 4 plus 2 to get 17 over 4. We've isolated the squared portion here. So now we can take the square root. So x plus 3 over 2 equals plus or minus square root 17 over 4. They simplified a little bit. X plus 3 over 2 equals plus or minus root 17 over 2. And then subtracted the 3 over 2 and combined it all into one statement. So this does break up into two solutions, a positive and a negative portion, but I am a-okay with you leaving it just like this. Negative 3 plus or minus root 17, that quantity divided by 2. So let's see if we can get us a little bit of a nicer numbers here. So we've got the equation x squared minus 2x plus 7 equals 0. So first thing we want to do is we want to move our numbers over to the other side. So x squared minus 2x is equal to negative 7. So now we identify b. So b is that middle coefficient. So that's negative 2. So we take that b term, negative 2, divide it by 2, and square it. So negative 2 divided by 2 is 1. 1 squared is just 1. We will add that to both sides. Add 1, add 1. They messed up a little bit here, so this should still be minus 2x and then plus 1 and negative 7 plus 1. So again, the way we created this is that this should be a perfect square. So it comes out to x minus 1. Again, this is that b over 2 term. Negative 7 plus 1 is negative 6. Now we take the square root. So x minus 1 equals plus or minus the square root of negative 6. Moving over that 1 to the other side, we'll get x is 1 plus or minus the square root of negative 6. Now you'll notice we should have non-real solutions. 1 plus or minus I root 6 and, 1 plus I root 6 and 1 minus I root 6 are going to be our two solutions. So how many complex solutions do the parts in A and B have? Well, they had two complex solutions each. Remember, all of our solutions are complex because the complex numbers include the reals and the non-reals. So let's try a couple more examples here with completing the square. So first thing we need to do, we'll need to subtract the 17. Now we will add the b over 2 term to both sides. We can rewrite it then as our perfect squared term there. Now 8 over 2 is 4. 4 squared is 16. So, might help if I do this correctly. When I moved over the 17, I forgot I need to be subtracting it. So negative 17 and then plus 16 gets us to negative 1. Well, 8 over 2 is the same thing as 4, so when we take the square root, we'll get 8 over 4 is plus or minus the square root of negative 1. So we subtract the 4, x equals negative 4 plus or minus, well, the square root of negative 1 is the same thing as I, which means we will have two non-real solutions.